In the previous video, we have made the geometry of this aerofoil from the coordinates. And in this video, I will be creating a center point for rotation and also the scaling location. So around that point, basically, we will rotate the aerofoil for the given twist angle. And as well as along the around that point, basically, you will scale the geometry of this aerofoil to get the required chord length. And for that you have to edit the sketch. So just click here and then you will be seeing these options, and click on the edit sketch. After doing that thing, you have to select the point, and I will place this point exactly on the origin, which is just on the leading edge. So you should be careful that this point should be exactly placed on this origin location with the two arrows for the x and y coordinates. And so what conditions we have right now for this coincidence 3 and coincidence 4, and also include the fixed condition, so that this point will be fixed in the space and it will not move under any conditions. Second thing is that I will be creating a line, and this line will be a chord line. So I will join the 2 points, this origin point to the trailing edge. And here exactly we should be having the length of this line should be equal to 1, which is the chord length of this aerofoil. For generic aerofoils, the chord length are always 1 units. And units here are the meters. So we are going to get the 1 meters here. Okay, now after getting the line, just press the escape key and zoom the geometry. And now I will be making a 1 point. So this can be anywhere on this line. Simple. And next thing is that I will be deleting the coincidence relationship between the line and the point, because when I delete the line, the point will also be deleted because of this relationship. So I don't want to keep this relationship here. Simply right click here and click on the delete. And then press the escape key and also delete this point. And then select this line and delete this line also from the keyboard. Just press the delete key. And you can see that we are able to keep this point. And since we should be creating this point at the 30% location, so for the 1 meter chord length, this will be equal to 0.3 of the length. So 0.3 meters, it should be away from the origin point. And here we have the small dimensions, and make dimensions between this point, which is just on the origin, and this point. And now provide the dimensions to be equal to the 0.3 and press the enter key. And just make sure this point should be only moved. So sometimes if you don't fix this point will be moved, and you will see distortion in aerofoil. So always check this thing, that the aerofoil should be intact and it should be going through these coordinates. And in any case, if you see any problem, then you have to undo and then fix the things and then move on. Okay, so right now we are done with everything here. We created this point, and we place this point at 30% chord location as given in our reference table. And this table says that the coordinates for where the motion of where the twist angle is to be provided is at the 30% of the chord. So for the base aerofoil, this will be 0.3, but for different aerofoil, this will be 30% of that current chord length, which is, for example, on this location of radius 1.257 meters, this is 0.737, and 30% location of this one would be different. Okay, so now I will be ending the sketch here. And so I will return the sketch to the unedited mode. So after creating this point, And whenever you apply any other operation on this aerofoil or this sketch, you have to again edit the sketch. So also I want to tell you that I have different files, so which are saved with the different names. So step 2, step 3, step 4, and so on.